Welcome to our NLP class. This is part 14. In this class, we are going to study about one of our word embedding technique, which is using vector space. How do we represent our text into numerical vector? So, this is our entire corpus and we want to represent this corpus into a numerical vector. So, here is a mapping function. We have seen lot of mapping function which includes bag of word method, TF and IDF, and so many different techniques we can use to convert these text into numerical vectors. This is numerical vector. Next one is how do we understand this numerical vector and how do we intelligently use this numerical vector and then derive some output. So, whatever output we want to have. So, let us consider an example. This corpus has 3 different documents, maybe document 1, 2, 3, and one document is related to machine learning, another document is related to AI, another document is related to farming. Now, we study type of word presented in all these 3 documents and trying to understand what is the similarity between these 3 documents. Similarity between these 3 documents by analyzing the words given in those documents. So, now first step is to convert this into numerical vector. How do we convert? Maybe looking at the frequency of those words. Just for an example, just take 2 words. One is data and another one is sample. And just take a count of these words in all these 3 documents. One is machine learning, another one is AI, third one is food. So, we are just looking at the frequency. Let us assume that the frequency is like this. The ML has 6000 words, this one has 4000 words, and AI has 4000, and this one is 2000, and maybe last one has 2000 and 5000. Now, we have our vector space, 3 different vector. So, just for our simplicity we can reduce this 6, just remove 3 zeros and make it as a simple number, so that it is easy for us to do simple calculations. ML has 6 and 4, this is our first vector, and A is 4, 2, and food is 2 and 5. Now, can we use that 2-dimensional vector space to represent these 3 documents in a plot, so that it is easy for us to visualize and see how these words are represented in the vector space. So, in the vector space, what we can do is we can take this data as in one axis and sample in another axis. This is data and this is sample. And how do we plot these vectors on this space? Just try to plot this word ML. In x axis it is 6 and in y axis it is 4. And this comes here. So, this is our first vector. Let us consider this is vector A and this is vector B and this is vector C. Now, we have our vector A. And can we represent this vector b, ai, or vector b? Vector b is 4 comma 2. This will be coming here, this is 4 and here is 2. Let us consider this is 2. This is our vector b. And third one is 2 and 5. This is 2, 5. This is our third vector, vector c. Now we have converted all our documents. So initially we had three documents. It was simpler enough for a human being to read and understand. Now we have converted this entire text into a mathematical representation on a 2D plane. So in reality it can be at any dimension, the plane could be at any dimension. Right now we have considered only 2 words, data and sample. If we have considered n number of words, then this can be represented in a n dimensional space. So this will increase. Now let us consider how we can understand the similarity of these two documents. ML is our vector space A and A is vector space B. How do we understand the similarity between A and B? So one way to understand the similarity is measuring the distance between these two vectors. Measuring the distance between two vectors. One way is using the Euclidean distance. Euclidean distance. So this one is just join this B and A and measure this distance. How to measure this distance? This is just using our Pythagoras theorem. Just let me give you an example that if we have our simple vector A which has A1 on x axis and the coordinate on y axis is A2. We want to measure this vector distance, which is called as norm of this vector, which is called as L2 norm. L2 norm of this vector. This L2 norm of this vector can be calculated using our Pythagoras theorem. This distance on x axis is A1 and on y axis is A2. Then L2 norm is equal to A1 squared plus A2 square. So using this same principle, we can calculate the distance between A and B. How do we do this? Just project this on this x axis, we will end up having another triangle. Just constructs this triangle and understands this value. What is this distance and what is this distance? We know that this is 4, sorry, this is 6 and this one is 4. Now this distance on x axis is 6 minus 4. Is this correct? This distance is 6 minus 4, and here we just name it as this A and just name this one as B. Then this A is 6 minus 4 and B is, when you project it on y axis, this is 4 and this is 2. Then B is 4 minus 2. Now we have A and B, then using the Pythagoras theorem, we can calculate the distance between vector A and B, which is the norm AB. This norm AB is equal to this A squared plus B squared. What is this A squared? A squared is 6 minus 4 the whole square plus 4 minus 2 the whole square. What is the 6? The first point. Maybe we can call this was an A1, A2 and this one as B1 and B2. So, when you generalize this formula becomes the norm of AB is equal to as A1 minus B1 the whole square plus A2 minus B2 the whole square. And when you calculate this, simplify this equation, which becomes 6 minus 4, 2, 4 and this is 2, 4, which becomes root 8. Similarly, can we calculate the distance between A and C? Similarly, we can calculate the distance between A and C, this distance. Yeah. So, now for the document C, we know C1 and C2. Then calculate the distances. For A and C, the norm AC becomes A but minus C1 square plus A2 minus C2 the whole square. Then you apply on vector space, let me 6, 4, 2, 5. A is 6, 4 and B is 2, 5. So, the Euclidean distance or the norm becomes 6 minus 2 the whole square plus 4 minus 5 the whole square, 16 plus 1, which is equal to root 17. Now, we can look at the distance and then compare the distance between A and B. This is the distance between A and C. So, A and C is root 17 and you look at this previous one, here we see root 8. This is root 17 and this distance is root 8. Now, we can understand which document is closer to which one. So, the distance between A and B is very small compared to the distance between A and C, which actually telling us the story that the machine learning and AI are more related than the machine learning and food, this document. So, yeah, so this is a very elegant and simple way of understanding the document and comparing similar document just by looking at the vector space. Just convert everything into a vector and a numerical vector and then compare those numerical vectors using the multidimensional vector space using this simple Euclidean metric. And not only this Euclidean measure is very useful, and sometimes we do have other approaches to measure the similarity. Another method is called as cosine similarity. Sometimes Euclidean distance will not work. We will see why do we need cosine similarity metric and what is the usage of cosine similarity metric. So we will see that in our next class. Thank you. Bye.